You ever have that moment you write some Pandas code, it runs like a dream. Then you add just one more column, run a similar operation, and suddenly it grinds to a halt. We've all been there. It's one of the most common frustrations for data scientists, and today we're going to pull back the curtain and find out why it happens.
So here's our game plan. We'll start by digging into that performance mystery in Pandas. Then we're going to peek under the hood at its hidden engine, the block manager, and see why it can be so costly. After that, we'll check out a whole new approach with a language called Mojo and its data frame library. And finally, we'll see what this all means for the future.
All right, let's kick things off with Section 1, Pandas Performance Mystery. We're getting to the why behind that inconsistent speed. I mean, this is the question, right? It's what we've all muttered to ourselves at our keyboards. Why does the exact same kind of operation sometimes feel instant and other times not so much? It feels like you're rolling the dice when all you want is consistency. And look, it's not just us. This quote from a deep dive into Pandas internals just hits the nail on the head. If an expert can't even tell you how long a simple slice assignment will take, you know there's something weird going on. And that classic answer, it depends, well, we're about to find out exactly what it depends on. So here's the big reveal. And it's actually good news. You can stop blaming your code. Seriously, this isn't about you being inefficient. The real culprit is a fundamental piece of Pandas architecture, a hidden layer that's responsible for all these little performance headaches. Okay, so let's pull back that curtain. It's time to dive into Section 2 and meet the thing at the heart of this mystery, the block manager. So, how do you picture a data frame in memory? Most of us have this mental model on the left, right? It's just a collection of columns, and each column is its own thing. Simple. But that's not actually what's happening. The reality is that Pandas is busy grouping any columns that share the same data type into these big, single chunks of memory called blocks. And this is the block manager's whole job. It's this internal component working behind the scenes that does all this organization. So if you have, say, 2 integer columns and 5 float columns, you don't have 7 separate arrays. You have 2 blocks, one for the integers and one for the floats. They're all living together now. Now, there is a method to this madness. The big pro is that if you're doing an operation on columns inside the same block, like adding 2 of your integer columns, it's incredibly fast. But, and this is a big but, it comes with some serious cons. The code gets way more complex, it can hide how much memory you're really using, and worst of all, it creates this super expensive process called consolidation.
And let's focus on that last one, because it's huge. Welcome to Section 3, the cost of consolidation. This is the performance trap that gets so many of us.
Okay, just walk through this with me. You start with a nice data frame, 2 integer columns, living happily in one efficient block. Then you add another integer column. For a split second, it lives in its own new tiny block. But then, pretty much any operation you do next triggers something called consolidation. And here's the kicker. Pandas has to create a brand new, bigger block in memory and then copy all the data from the first 2 columns plus the new column into that new space. That's a massive, hidden copy operation, and that's why your code suddenly slows to a crawl.
So if the block manager architecture has this built-in flaw, what's the alternative? Well, that brings us to Section 4, and a completely new language that was designed to avoid these kinds of problems from the get-go, Mojo. Simply put, Mojo is a fresh take on what a programming language for AI and data science should be. It was built from the ground up for the kind of performance and scale that modern problems demand and to take full advantage of modern hardware like multi-core CPUs and GPUs. So what's its secret sauce? Well, first, it uses a Python-like syntax, so it feels familiar. But under the hood, it's a completely different beast. It uses what's called just-in-time or JIT compilation to turn your code into lightning-fast machine code on the fly. This lets it talk directly to the metal, your CPU and GPU, and just absolutely crush the tensor operations that are the bread and butter of modern data science. And when you have a new language, you can build new tools with totally new designs. Which leads us to Section 5, the Mojo Frame Blueprint, a fundamentally different architecture for data frames. Mojo Frame is exactly what it sounds like, the first data frame library built natively in Mojo. The entire philosophy behind it is to use Mojo's incredibly fast tensors and to sidestep the architectural traps we saw in Pandas, like all that hidden data copying and consolidation. And when you put them side by side, the difference is just night and day. Instead of that complex block manager, Mojo Frame uses a much simpler model built on those high-performance tensors. It even has a smarter way of handling strings. It's cardinality aware, which is a fancy way of saying it looks at your text and figures out the most efficient way to store it based on how many unique values you have. Let's look at a real-world example, like a group by aggregation.
Pandas has to do this clunky column-by-column process to build up its keys. Mojo Frame does something much more elegant. It essentially flips the data on its side first, which allows it to create all the keys it needs in one single clean pass. It completely avoids the inefficiencies of the old way.
Okay, a new architecture sounds really nice in theory, but does it actually deliver? Let's get to the part we've all been waiting for. Section 6, the future of data frames, with some benchmarks and takeaways.
All right, take a look at this chart. This is performance on a query that's heavy on user-defined functions, or UDFs, which we all know can be incredibly slow in Pandas. We'll set Pandas as the baseline at 100%. Now, Polars, which is already a super fast library, slashes that runtime down to just 16%, a massive improvement. But then, look at Mojo Frame. It clocks in at a staggering 3.5%. That isn't just better, that is a completely different world of performance.
Just to put that in perspective, that means Mojo Frame is over 4.5 times faster than Polars, the next best thing, on these kinds of complex queries. And that's all thanks to Mojo's ability to compile that custom logic and run it in a highly parallel way across your CPU.
So what does this actually mean for you day to day? Well, first, it means predictable performance. No more hidden costs, no more it depends. Second, it means your custom functions are no longer a major bottleneck. They can actually be fast. And third, it really signals a whole new mental model where our tools are finally built to leverage the power of modern hardware instead of being held back by legacy designs.
And that really brings us to the final thought. As our data problems get more complex and our computers get more and more powerful, are we finally entering a new era? Are we witnessing a fundamental shift where we leave the old architectures behind for new tools that are truly built for the future? It's going to be a very exciting time to find out.